Imagine you're watching a friend drift away into the most silent, most terrifying place in the universe. From your perspective, as you watch from the safety of a nearby spacecraft, something impossible begins to happen. As they approach the invisible boundary of a black hole, their movement begins to slow down. They don't scream, they don't wave frantically, and they certainly don't disappear in a flash of light. Instead, they linger. They become a ghost, a motionless statue pressed against the fabric of reality, turning a deep, bruised red before fading into a permanent, frozen silence. To you, they are trapped in time, a photograph that never finishes developing. But for your friend, the reality is far more violent and far more immediate. They aren't stopping at all. They are falling at a speed that defies logic, heading toward a destination where the laws of physics don't just break, they vanish. This is the great cosmic tragedy of the black hole, a single event told in two completely different languages, where the truth depends entirely on who survives to tell the story. To understand why this happens, we have to look at the very ground we stand on, or rather the emptiness we move through. We used to think of space as a stage and time as a clock on the wall, both independent and unchanging. But Albert Einstein realized they are woven together into a single fabric called spacetime. Gravity isn't just a force pulling on your boots, it's the way that fabric curves. A planet makes a small dent, a star makes a deeper one, but a black hole is a bottomless pit, a puncture wound in the universe that stretches the fabric of time itself until it snaps. When you stand near a massive object, time actually moves slower for you than it does for someone in deep space. It's a proven fact measured by atomic clocks on satellites and mountain peaks. But at the edge of a black hole, this effect is taken to its ultimate terrifying conclusion. As your friend approaches the event horizon, the point of no return, the gravity becomes so intense that time begins to stretch like a piece of cosmic taffy. Every second they experience takes years, then decades, then centuries in your world. From your vantage point, you see the light reflecting off their suit, struggling to climb out of that gravitational well. Light loses energy as it fights the pull, shifting its color toward the red end of the spectrum. This is gravitational redshift. Eventually, the light becomes so stretched, its wavelength so long, that it passes out of the visible spectrum entirely. Your friend doesn't just stop, they dim. They become a faint crimson shadow, forever etched onto the threshold of the abyss, never quite crossing it in your eyes because, in your timeline, it would take an infinite amount of time for them to reach the edge. But let's follow the traveler. For them, there is no frozen moment. There is no wall, no glass pane, and no signpost that says, "Abandon hope." If the black hole is large enough, a supermassive giant like the ones at the center of galaxies, the traveler might not even realize they've crossed the event horizon at first. To them, the clock on their wrist ticks normally. They look back and see the universe they left behind, but it looks strange. The light of the entire cosmos seems to compress into a small, bright circle behind them, a kaleidoscope of stars accelerating as if the universe is rushing to finish its own story. Then, the geometry of the universe begins to betray them. Inside the event horizon, space and time effectively swap roles. In our normal world, we can choose to move left or right, forward or back, but we are forced to move forward in time. Inside a black hole, the direction toward the center, the singularity, becomes your future. You can no longer choose to move away from it any more than you can choose to move backward into yesterday. Every direction you turn, every burst of your thrusters only brings you closer to the end. This is where the physical reality becomes a nightmare of engineering. We call it spaghettification. Because the gravity increases so sharply over such a small distance, the pull on your feet is significantly stronger than the pull on your head. You are stretched thinner and thinner until your very atoms are pulled into a vertical line of plasma. You are no longer a person. You are a stream of information falling toward a point of infinite density. Yet, this creates one of the greatest paradoxes in all of science. a mystery that kept Stephen Hawking awake for decades. If you are destroyed and crushed into the center, but an observer outside sees you frozen on the surface forever, where is your information? Quantum mechanics insists that information can never be truly destroyed. If you were to burn a book, you could theoretically reconstruct its pages if you tracked every molecule of smoke and ash. But if you fall into a black hole, the universe seems to have two copies of you, one dying in the center and one preserved as a shell on the surface. This led to a breathtaking discovery known as the holographic principle. Some physicists now believe that the event horizon isn't just an empty boundary, but a sort of 2D storage device. Everything that falls into a black hole is encoded onto its surface, much like a hologram on a credit card. If this is true, it suggests something profound about our entire existence. If a three-dimensional person can be perfectly represented by two-dimensional information on the edge of a black hole, then perhaps the three-dimensional universe we live in is just a projection of information stored on the distant edges of space. We used to view black holes as cosmic erasers, simple traps that removed matter from the map. Now we see them as the ultimate archives, the hard drives of the universe. They are the places where the laws of the very large, gravity, and the laws of the very small, quantum mechanics, clash in a battle for the soul of reality. They challenge our definition of now and here, proving that even the most solid facts of our lives are subject to the curve of the void. When you look up at the night sky, it feels permanent and stable. But out there, scattered across the dark, are these silent points of no return. They are places where time has effectively ended, where our friends and our stars stay frozen in a ghostly amber, while in another reality, they have already been woven into the very fabric of the cosmos. We are living in a universe that refuses to be simple, a place where a single moment can last forever, and where the end of a journey is just the beginning of a different kind of existence. In the end, falling into a black hole isn't just about death or destruction. It is the ultimate test of what it means to be real. It teaches us that our perspective is just one thread in a much larger tapestry. We are observers of a grand, terrifying clockwork, where time is not a straight line but a river that can be bent, slowed, and eventually stilled. And as we stare into that darkness, we don't just see the end of light. We see the limits of our own understanding, frozen in time, waiting for us to finally bridge the gap.